Good morning, children. Today I am going to start the revision. The 10th standard students, those who are going to write the public exam, for them I am going to start the revision in science class, that is science first. Today, children all are well, I think. Daily study the portions. Today onwards you start to study daily 1 words, 2 marks, big questions, problems like that. Every day you have to revise the portion. You split the days and give the timing for all the subject and study well. Science also study well. Practice the problems and derivations in rough notes. Now all of you take the books. First we have the books, science books. All of you take the science books and start to study. Okay. Now I am going to give revision. You follow me. Whatever I am giving, now you study. Then you proceed it later. Then all the remaining questions, big questions, that and all, the remaining time you have to study. Okay. Now we are going to revise the first lesson. The first lesson is laws of motion. Okay. In this lesson, we have learned 1 words, 2 marks, everything. First, today we can read the 1 words first. Okay. First, choose the correct answer. Some questions we can learn, then remaining you have to study. Okay. We have given already. So everything how we have learned, in that way you have to study well. Okay. Choose the correct answer. One by one I am saying the questions. You have to recall it. Okay. Then inertia of a body depends on. The 4 choices are there. What is the correct answer? Mass of the object. Okay. Next question. Impulse is equals to change in momentum. Next. Plotting a graph for momentum on the x-axis and time on the y-axis. Slope of momentum time graph gives, what's the answer? Force. Okay. Now, in which of the following sport the turning of effect of force used? Which sport? Cycling. Cycling is the correct answer. The unit of G is ms or -2. It can be also expressed as N kg per -1. That means Newton kilogram per -1 or Newton by kg. Okay. So, B is the correct option. Next. 1 kilogram force equals to, that is 98 into 10 power 4 dyne. Okay. Then, if the earth shrinks to 50% of its real radius, its mass remaining the same. The weight of a body on the earth will decrease by 25%. Okay. Like this all the questions. All the questions you have to learn well. Okay. Filling the blanks. Then we can learn the filling the blanks. Some questions, few questions we can revise. Okay. To produce a displacement, dash is required. Force is required. Then passengers lean forward when sudden brake is applied in the moving vehicle. This can be explained by inertia of motion. By convention, the clockwise moments are taken as positive. That given dash. Then and the anti-clockwise moments are taken as dash. So, clockwise moments are taken as negative and the anti-clockwise moments are taken as positive. Okay. Like this, remaining all the 1 words we have to learn thoroughly. Now, we are going to learn the answer, small definitions and answer briefly. That questions we are going to learn. Okay. Now, all of you recall it. So, remaining questions also you have to learn well. First question, inertia. Define inertia. in the page number 2 and 3. For this question will come for 2 mark and that some big questions also. Okay. So the page number 2, the definition for this inertia is there. What is the definition? The inherent property of body to resist any change in its state or the state of uniform motion, unless it is influenced upon by an external unbalanced forces known as inertia. All of you once more say along with me. Okay, say along with me. You know already. So you once more this answer, the definition for this inertia, you have to say along with me. The inherent property. This inertia is the inherent property of body to resist any change in the state of rest or of uniform motion, unless it is influenced upon by an external unbalanced force. It is known as inertia. Okay. So, what are the classification? Give its classification. The classification of this inertia. There are 3 classifications. The types are there. Inertia at rest. We know. Inertia. You say along with me while hearing time. While I am saying time, you say along with me. Open the book and say along with me. Inertia at rest. Inertia of motion. Inertia of direction. Okay. First, inertia of rest. So, what is inertia of rest? The resistance of a body to change its state of rest is called inertia of rest. Say once more, say along with me. The resistance of a body to change its state of rest is called inertia of rest. Okay. Next, inertia of motion. What is inertia of motion? The resistance of a body to change its state of motion is called inertia of motion. Next, third, inertia of direction. What is inertia of direction? The resistance of a body to change its direction of motion. Okay. So, inertia of rest, the resistance of body to change its state of rest is called inertia of rest. Inertia of motion, the resistance of a body to change its state of motion is called inertia of motion. Inertia of direction, the resistance of a body to change the direction of motion is called inertia of direction. We can write here. First, inertia of rest. Second, inertia of motion. Third, inertia of direction. We know the examples also. Okay. What's the example for this inertia of rest? When you vigorously shake the branches of a tree, some of the leaves and fruits are detached and may fall down. This is the example for inertia of rest. What's the example for inertia of motion? An athlete runs some distance before jumping because this will help him jump longer and higher. This is the example for inertia of motion. Then what is the inertia of direction? What's the example for inertia of direction? When you make a sharp turn while driving in a car, you tend to lean sideways. A direction is changing. So it is the direction of inertia of direction. This is the example for inertia of direction. Okay. Next, you learned these questions, I think. You recalled it. So we can learn the next question. Types of forces. Okay. Types of forces. Based on the direction where the force is acting, according to that, we can classify the 2 types. They are like parallel forces, unlike parallel forces. Okay. Based on direction of the force, we can classify it into 2 types. Like parallel forces unlike parallel forces. Parallel forces, unlike parallel forces. What are like parallel forces? Two or more forces equal and unequal or unequal magnitude acting on the same direction. Equal or unequal magnitude acting along the same direction and parallel to each other are called like parallel forces. They are equal or unequal. That magnitude is no problem, but they are acting along the same direction and they are parallel to each other. Such forces we can say as like parallel forces. Okay. What are unlike parallel forces? If two or more equal forces or unequal forces act along opposite direction. Like parallel forces, same direction. Here unlike parallel forces, equal or unequal magnitude forces only, but they are acting along opposite direction and parallel to each other. Okay, so they are called unlike parallel forces. Okay, next this one according to the direction of the forces. Next, according to application. What are the application? We can get some use because of that forces. There are, that is another types. That is also because of that is also types of forces only. Okay, so that is balanced forces, unbalanced forces. Okay, balanced forces, unbalanced forces. What are balanced forces? The answer is in the page number 4. Okay, you know, the answer is in the page number 4. That is the second question. Classify the types of force based on their application, because these forces are helping us to draw water from the well. Then it is, we can apply this force in the crowbar and in weight balance. Here we are using this balanced forces and unbalanced forces. Okay, so these are used. This one we can bring under the category of forces based on their application. Okay, so if the resultant force of all the forces acting on the body is equal to 0, then the body is in equilibrium. So the resultant force acting on the body is 0. That body is in equilibrium. Such forces are called balanced forces. The forces are balancing one another. Okay, so that forces are called, the forces which are acting in the body, that forces are called balanced forces. Then what is unbalanced forces? This unbalanced force is the resultant force is not equal to 0. The resultant force acting on object is not equal to 0. It causes the motion of the body. It is producing some motion in the object. That is called unbalanced forces. Okay, children, all of you understood, you have learned, I think. Next, differentiate mass and weight. Differentiate between mass and weight. We have written in the book itself, we have drawn table. So first some points we have written. So what is mass? What is weight? For differentiation, we have to draw the table and write the answer as point length. Okay, point wise we have to write the answers. Okay, what is mass? The mass. So mass is the basic property, fundamental property. Weight is the derived. Okay, so first point, mass is the fundamental quantity. Derived is the weight is the derived quantity. Second one, mass. What is the definition of mass? The quantity of matter contained in a body. Weight. It is defined as the gravitational force exerted on the body due to the gravity alone. Okay, that is the second point. Next, the third is the SI unit of mass is kilogram. The SI unit of weight is Newton. Okay. So mass is constant, but weight varies place to place. Okay. So weight is varying place to place. So these are the points in the distinguish between mass and weight. Okay. Next, define moment of a couple. That points. Once more, you see, children. Differentiate mass and weight. This answer I told like in the table, but as like paragraph, you can see in the page number 10. Okay. If you take the book, the page number 10, we can see the answers in the point wise. You can find out easily. Now, define moment of a couple. Answer is in page number 5. Define moment of a couple. What is moment of a couple? You see, two equal. If you know the answer, you can you remember well. You can say along with me. Two equal and unlike parallel forces applied simultaneously at two distinct points constitute a couple. A couple results in causes the rotation of the body. This rotating effect of a couple is known as moment of a couple. Okay, once more I am saying, see, two equal and unlike parallel forces applied simultaneously at two distinct points constitute a couple. A couple results in causes the rotation of the body. The couple producing the rotation of the body. Rotating effect of a couple is known as moment of a couple. Okay, I am writing the question. Moment of a couple. This question only. This question's answer only we have learned now. Okay. Next question. State the principle of moments. We have to write the statement. State the principle of moments. You see, the answer for this principle of moments you can see in the page number 5. Page number 5, last paragraph, and the page number 6, first 2 lines we have the answer. Okay. So, you see, I am saying along with me, you say, when a number of like and unlike parallel forces act on a rigid body and the body is in equilibrium, then the algebraic sum of the moments in the clockwise direction is equal to the moments in the anti-clockwise. The algebraic sum of the moments in the anti-clockwise direction. Okay. Say once more we can say this. When a number of like and unlike parallel forces act on a rigid body and the body is in equilibrium, then the algebraic sum of the moments in the clockwise direction is equal to the algebraic sum of the moments in the anti-clockwise direction. Okay, this same statement you can say in some other words. In equilibrium, the algebraic sum of the moments of all the individual forces about any point is equal to 0. While writing this statement, we have to write the formula also. F1 into D1 is equal to F2 into D2. Okay. So, algebraic sum of the moments in the clockwise direction is equal to the algebraic sum of the moments in the anti-clockwise direction. Okay. All of you, no. Now, we can start the next question. Next one, state Newton's second law. State Newton's second law. State Newton's second law. What is Newton's second law? That answer is in page number 6. All of you know, but I I am saying the page number, how to take that page number and listen to me and say along with me. State Newton's second law. What is Newton's second law? The force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum take place in the direction of force. Okay? So what is the definition? Say, repeat along with me. The force acting on a body is directly proportional to the linear momentum, and the change in momentum take place in the direction of the force. And the change in momentum take place in the direction of the force. Once more, the force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum take place in the direction of the force. Okay? All of you know. Next, the formula for this is F is equal to ma. This is the formula for Newton's second law. Next question. While catching a cricket ball, the fielder lowers his hands backwards. Why? What's the question? While catching a cricket ball, the fielder lowers his hands backwards. Why? Answer is in page number 7. First column, last paragraph. The answer is there. You see, in cricket, the fielder pulls back his hands while catching the ball. He experiences a smaller force for the longer interval of time to catch the ball, resulting in a lesser impulse in his hands. So he is bringing back, okay, backwards, lowering backwards his hands. Now, next question: how does an astronaut float in the space shuttle? How does an astronaut float in the space shuttle? Answer is in page number 11. All of you take the page number 11. Second column, last paragraph. You see there, astronauts are not floating but falling freely around the air due to their huge orbital velocity, since space station and astronauts have equal acceleration. They are under free fall condition. Okay, they are under free fall condition. So once more we can repeat this. Astronauts are not floating but falling freely around the earth due to their huge orbital velocity, since space station and astronauts have equal acceleration. They are under free fall condition. Okay. Now, so some more questions we can see here. Some more questions. Other Newton's second law we have learned. The other Newton's first law is there. Newton's third law is there. Newton's first law is in the page number 3. Newton's first law is in the page number 3. What is Newton's first law? Shall I repeat? What is Newton's first law? Every body continues to be in a state of rest or of uniform motion along a straight line unless it is acted upon by some external force. Okay, that is Newton's first law. Say once more. Every body continues to be in the state of rest or the state of uniform motion along the straight line unless it is acted upon by some external force. That is Newton's first law. Okay. Now Newton's third law. Newton's third law is in the page number 7. Okay. Newton's third law is in the page number 7. What is Newton's third law? For every action there is equal and opposite reaction. They always act on two different bodies. there is equal and opposite reaction. They always act on two different bodies. That is Newton's third law. Now you know Newton's first law, Newton's second law, Newton's third law. Okay. Next, another law is there. State the universal law of gravitation. State the universal, that is also called as Newton's universal law of gravitation. Okay, what is Newton's universal law of gravitation? For that we have the formula. From the formula itself we can say that okay. You see here Newton's universal law of gravitation. Every particle in the matter in the universe attracts every other particle with the force. Okay, that force only F. The force. This force is directly proportional to the product of the masses and inversely proportional to the square of the distance between the centers of their masses. The direction of the force acting along the line joining the masses. Okay, so F is the force, M1 is one mass, M2 is another mass, R is the distance between the two masses. Okay, so once more you say along with me that laws, whatever we have in the book, same thing you have to study correctly. Every particle of matter in the universe attracts every other particle with a force. This force is directly proportional to the product of their masses. Okay, and inversely proportional to the square of the distance from the centers of their masses. Okay, so for example, we can see this. This first one is M1, first mass. Second mass is M2. This is the centers. The distance between the centers of the masses is that mass center distance we can take as R. Okay, this first the object which have mass M1 that is acting one force upon the mass M2, M2 applying a mass upon M1. Okay, so this only Newton's universal law of gravitation. You have to know correctly. So once more we can say every particle of matter in the universe attracts every other particle with a force. This force is directly proportional to the product of their masses and inversely proportional to the square of the distance between the centers of their masses. The direction of the force acts along the line joining the masses. Okay, so this universal law of gravitation, this here F is equal to capital G M1 M2 by R square. Okay, instead of this proportional, we want to write equal to and one constant. This capital G is called as constant. This constant is called as universal gravitational constant, capital G. Thus, SI unit is Nm square kg per minus 2. The value of this universal gravitational constant is 6. Capital G is equal to 6.674 into 10 power minus 11. Nm square kg power minus 2. This is the value of capital G, children. Some questions we have revised today. So that questions today thorough. Then if you want to study more, the problems and big questions, everything you can learn today. Okay. So whenever you have time, you take the books and study. Don't waste the time. Okay. Thank you.